NASA's most developed and most powerful machine, the James Webb Space Telescope, or JWST, was put into operation 6 months ago. Since it predicts some of the most amazing developments in our solar system, this telescope, which replaces the Hubble telescope, will be excellent for many years. The James Webb Telescope has already started its scientific mission to unreveal the mysteries of our universe. Webb released the first set of images on July 12. Since then, there has been a lot of debate about these images. Some of the Webb telescope's shocking discoveries are proving our modern cosmological theory wrong. It does not mean that these discoveries proved the Big Bang model completely wrong. But it remains to be seen how long the Big Bang theory holds true, because new discoveries from the James Webb Telescope have taken the world of science by another storm. So, ladies and gentlemen, fasten your seat belts because the weather is about to change. Well, we have already seen how Webb's early galaxies are challenging our current galaxy evolution model, called Lambda CDM or LCDM. This model incorporates scientists' best estimates for the properties of dark energy and dark matter, which collectively act to dominate the emergence of large-scale cosmic structures. Where lambda refers to dark energy, and CDM refers to dark matter that is relatively sluggish or cold. But the recent discovery of the oldest dark matter by the James Webb Telescope has brought this cosmic model to another debate. Before understanding this, let us see once a discovery from the Hubble telescope which was already making this claim.
Most astronomers currently believe that dark matter plays a fundamental role in our universe and the formation of galaxies. This is because galaxies seem to have a lot more mass than what we can account for based on just the stars we see. How much mass is in a system is determined by measuring the speed at which galaxies rotate or individual stars in a galaxy move. Without the gravity from that mass, a galaxy would fly apart if everything in it is moving as quickly as we observe it moving. Decades of research have led astronomers to the extraordinary conclusion that 85% of the mass in our universe is invisible in all wavelengths of radiation, and that it's composed of matter that does not contain protons or neutrons or any type of particle we've detected before, and that this invisible material is all around us, passing through us without interacting with regular matter except by gravity. For some, that's a tough pill to swallow, and a minority of astronomers wonder if maybe we just don't completely understand how gravity works. If that were the case, and it was an inherent property of gravity that causes galaxies to move the way they do, then we could expect all galaxies to behave the same way. In other words, they would all seem to have about the same portion of dark matter. But with the galaxy in this Hubble image, astronomers looked at the velocities of 10 globular clusters in the galaxy, each a spherical collection of hundreds of thousands of stars, and calculated that their movements can be accounted for entirely by the mass of the visible material in this system. That means this galaxy has little to no dark matter. Strangely, this absence of dark matter actually provides evidence that dark matter is real. It shows that dark matter isn't always coupled with regular matter, that it's something separate. You can have regular matter without dark matter. This galaxy is really weird even beyond the dark matter thing. You may have noticed you can see straight through it. That's because this galaxy is what's called an ultra-diffuse galaxy, which, as the name implies, is extremely low density. This galaxy is about the same volume as our own Milky Way galaxy, but only has about 0.5% the amount of stars. Though astronomers have known about ultra-diffuse galaxies since the early 1980s, they can be difficult to find since they're so faint. A team of astronomers is using an array of telephoto lenses called Dragonfly to seek out these ghostly-looking objects. They obtained observations from Dragonfly, the Sloan Digital Sky Survey, the Gemini Observatory, and the Keck Observatory, then requested time on the Hubble Space Telescope to take a closer look at this unusual galaxy. Having images and data from multiple sources allowed the team to determine that this galaxy does not have a significant amount of dark matter. This was definitely surprising to find. No other galaxies so far have appeared to be so lacking in dark matter. In fact, other ultra-diffuse galaxies seem to have an overabundance of dark matter. The same team who studied this galaxy discovered a different ultra-diffuse galaxy in 2016 that they calculated was 99.9% dark matter. Yet another weird thing about this galaxy, the globular clusters used to measure the galaxy's rotation are way brighter than normal globular clusters. The researchers have written a different paper that focuses on just these oddball collections of stars. So this is a very strange galaxy in several ways. Astronomers will be looking at Hubble observations of other ultra-diffuse galaxies to see if there are any other examples of galaxies with unusually low or high amounts of dark matter. With more samples, astronomers will be able to better understand the nature of dark matter, the formation and evolution of galaxies, and the overall structure of our universe.
With the help of Webb's first deep field image, researchers have just studied the gravitational lensing of the oldest light we can see. The oldest dark matter that surrounds galaxies at the age of 12 billion years was discovered in it. When the James Webb Telescope recently took the famous image of the SMACS 0723 galaxy cluster, it was actually looking at ancient galaxies that had been enlarged by SMACS 0723. Including the oldest galaxy we've seen, formed just 300 million years after the Big Bang. Researchers found that dark matter in these most remote regions of space turned out to be less complex than it should correspond to the standard theory of cosmology. Hironao Miyatake, an astronomer at Nagoya University, said, "Our discovery of the past still remains uncertain. If the data is confirmed, it means that the whole model of the cosmological model has flaws. This will force scientists to refine existing models to improve our understanding of the nature of dark matter." JWST has been the springboard for an unprecedented era of science, and despite all the uncertainties, the rapid exchange of ideas as new discoveries are made and immediately publicized has invigorated astronomers. Now the question is, if we can truly believe what we are seeing, is it time to reappraise our understanding of the dawn of time? All these discoveries made by the Webb telescope are uncovering unknown mysteries of the universe that our theories failed to predict. With the help of the Webb telescope, we have seen such galaxies that were defying our galaxy evolution model. More upcoming programs are set to hunt for distant galaxies, such as Cosmos Webb, which is expected to hugely increase the population of early galaxies by observing a wider swath of sky for hundreds of hours. Some estimates suggest JWST could see as far as a redshift of 26, just 120 million years after the Big Bang, a cosmic blink of an eye. Scientists understand that just in the early universe, immediately after the Big Bang, there were some processes that they had not taken into account until now. Webb is so sensitive, it can see some of the youngest galaxies that formed just after the Dark Ages. We would expect those young galaxies to be less numerous and less developed than later galaxies. But the Webb telescope is showing us something else we didn't expect. It's why we wanted to build the Webb telescope in the first place. And it tells us that while the Big Bang model isn't wrong, some of our assumptions about it might be.